We don't have to go to another class right after this one. So please utilize that time if you have more questions that you want answered. We are here to help you. So flip to page number 8. So this one says a sports store sells about 50 mountain bikes per month at a price of $220 per bike. For each $20 decrease in price, about 10 more bikes are sold each month. Write a quadratic function in standard form that models the revenue from bike sales. How should I start making this quadratic function? Annabelle, how should I start making this quadratic function?
You can do the f of x equals 220 minus 20x times 50 plus 10x.
Yeah. Exactly. So what we're starting with, we're already selling about 50 mountain bikes for $220. That's where we got that first part from. And then the second part, they're saying if we decrease the price by $20, then 10 more bikes are sold each month. And that's where we're getting the second half of the price and the amount sold. When you go ahead and FOIL this function, you will get 11,000 plus 2200x minus 1000x minus 200x squared. So our function is negative 200x squared plus 1200x plus 11,000. So that was your function. How are we going to figure out what price produces the maximum revenue for part B? We want to get the maximum revenue. Ava R., how are we going to do that? How are we going to find the maximum?
So first you have to do x equals negative b over 2a.
Awesome.
And when you do that, it gives you 3.
Yeah. So then we have this x equals 3. Then what do we do with that?
And then you put it into the equation for x.
Awesome. And that's finding us our what? What is that finding us when we plug that 3 into the function?
That's finding you your y value.
Yeah. What did you end up getting?
12,800.
Perfect. Good. So now they're saying, what? So the question is, what price produces the maximum revenue? So we got that vertex, that maximum, which is 12,800, but we have to answer that question. What price produces the maximum revenue? What part of our function represents the price? Faith, what part of our function represented the price?
The $220.
Yeah, and the minus 20x following it. That's the price part of it, yeah. So we're gonna take that x of 3 and plug it in there to find the price. So we have 220 minus 2 times 3. 20, not 2. My bad. And when you do that, you end up getting 160. So our sports store needs to sell each bike for $160. So charge $160 per bike. So remember, once you find that maximum, that may not be the answer. You need to answer what the question's asking. Plug it back into the part of the function. And then part C is, what is the maximum monthly revenue? Gabby Snyder, what is our revenue here for part C? What's that maximum?
$12,800.
Yeah, that's 12,800. Was the maximum revenue. Like Ava R told us, it's that Y value, that's our revenue. Good. Questions on this one? So again, how we set up that function in part A is the same for all those problems. Set up those two binomials, put what you're starting with as the first number in both of them, and then what would change the second part. And again, if you have more questions on this worksheet, stay after class. I can assist you then, but we have notes to get through. The homework looks pretty good, so. All right, so go ahead and get your notes out. We are going to look on page 33, section 4.2. So we're still graphing here, but we're going to talk about two different forms and how they can benefit us from having it in different form. So vertex form we've talked about before. They would have us put our answers in vertex form before when we were completing the square. That's this y equals a times x minus h squared plus k. When we were completing the square, they would ask us to put our answer in vertex form sometimes. And it's called vertex form because you can get the vertex right from it. And we'll talk about that in a second. And then intercept form is y equals a times x minus p times x minus q. And so if we can read the vertex right off of that form of a vertex form, then we should be able to read the intercepts from the intercept form of the function. So the form's kind of telling us what we can read off the form right away. So let's talk about the graph of a vertex form. So the graph of y equals a vertex form is the parabola, y equals ax squared, translated horizontally h units. So that means it's going to go right or left h units, and vertically k units. We know this already. That k makes it go up or down, and that h makes it go right or left. Ella, what is our vertex from this form? What number, what letters there would be our vertex?
HK.
Yeah. Good. So we know from standard form that our axis of symmetry was the x value of our vertex. We'd use that axis of symmetry to find the y value, and that axis of symmetry was part of the vertex. So what do we think our axis of symmetry here is if we know our vertex is HK? What's our x value here in the vertex? Madison, what's our x value here in the vertex? The x coordinate.
The x.
Maybe I worded that tricky.
Are
So
you talking about h?
Yeah, H,
Okay.
yeah, exactly.
I thought you were asking for like a value. I was like, wait.
I used the wrong word there. I should have said x coordinate. Sorry about that. So yes, our axis of symmetry is going to be h here, that x coordinate of the vertex, just like how it was for standard form. The axis of symmetry is the x coordinate of the vertex. And we know if the graph opens up, then A is greater than 0, and down if A is less than 0. Okay. So now we are going to graph a quadratic function that is in this vertex form. And we're still finding all of the same things, the axis of symmetry, vertex, and the intercepts, those 4 main things. Let's start with the vertex. Lacey, what is our vertex here?
Is it -1, -2?
Exactly, yeah. Because that vertex form has that subtraction in front of the h, so if it's positive, then that h is negative. Awesome. So look up above. What is our axis of symmetry here? It says that it's h, which is the x-coordinate of our vertex. So for the example below, Alyssa, what is our axis of symmetry?
Would it be -1?
Yeah, x equals -1. Look at that. No math there. We get that vertex, we can see exactly what the axis of symmetry is. All right, moving right along, we have our y-intercept. We know we're setting x equal to 0. So I'm just going to go through, plugging in 0 for x. Then you're just solving. In that parentheses, we'll just get 1, and 1 squared is 1. So then this is just 1/2 minus 2, which is -3/2. So our y-intercept is 0, -3/2. Make sure you are writing it as an ordered pair. We set x equal to 0, and then got our output. And lastly, our x-intercept. So we're setting y equal to 0. So I'm going to go through and just plug in 0 for y. So when we were using standard form, how we've been graphing, we would see if we could factor or use the quadratic formula. What do you think you should do here? Think back to that solving quadratics cheat sheet that we talked about before your 4.3 to 4.8 test. What do we notice that we have here, and what would be the easiest to solve for x here? What would be your next step to solve for x here? Valerio, what would you do next to solve for x?
You would add the 2 to the other side and do square roots.
Yeah. So I'm going to kind of flip this around. I'm adding that 2, and then we still have that 1/2 x plus 1 squared. Just adding the 2 there and flipping it. So before we take the square roots, Valeria, what should we do? That binomial squared is not alone.
Divide both sides by 1/2.
Yeah, and the same thing as dividing by 1/2 would be multiplying by what?
2.
2. Yes, we can multiply both sides by 2. So we get 4 equals x plus 1 squared. And Valerio's right. We would take square roots here. We see that binomial squared. So we're always going to solve by taking square roots. When we have that vertex form, we're always going to have that binomial squared. Awesome. So we get x plus 1 equals plus or minus 2. And we have to subtract that 1. So we get -1 plus or minus 2. So then our 2x intercepts would be -3 and 1. I want to make sure I write those. It's ordered pairs. So when you have an answer like that right there where they're just whole numbers, you want to make sure that you separate it and get those two. Anytime you're getting x-intercepts, you want to separate it. All right, so now we have all the parts of this graph and we can go ahead and plot them all. So go ahead, we have our axis of symmetry, vertex, and intercepts. You would get these points from the values that we just solved for. What other point could we plot by using the axis of symmetry? Grace, what other point can we plot by using the axis of symmetry here, knowing that every point is reflected?
-2, -3 seconds.
Yeah, awesome. And we can see our parabola. So we will draw our curve. Nice. So some of you may like this form a little better. You don't have to use that quadratic formula for the x-intercepts. We would just use square roots here. All right, so go ahead and try part B. Find our 4 big things that we need: the vertex, axis of symmetry, y and x intercepts, and graph it. I'll give you a minute or two to do that. So it's okay if you're not done. Riley, what did you put as your vertex?
I put -3 and 1.
Okay, so let's look at the form. I agree, but there's one little thing. Look at the form of the vertex form. That negative is part of that formula. So, and our vertex is only HK. So what do you think our x-intercept should be here? Or not intercept,
+3.
x-coordinate. Yeah, +3. So be careful of that. Remember that that vertex form already has that negative in front of the H. So then Leah, what is our axis of symmetry here?
3.
Awesome. When we set x equal to 0 for our y-intercept, Julia, what did you end up getting for our y-intercept?
Did you get -19?
-19?
Yeah, I don't know. I don't know if I messed up somewhere or.
I think you are close. So we get -2 times +9. Negative 2 times 9 is negative 18. And then we're adding 1.
Oh, sorry. Negative 17.
It's a few off. Little adding mistake. Good. So we have 0, negative 17. And then we also have to find our x-intercepts. Jordan, walk me through the steps you took to solve for x here.
First I subtracted 1 from both sides.
Awesome.
And then I divided by negative 2 to get 1/2.
Good.
And then I took the square root of 1/2.
Mm-hmm.
And then I got x minus 3 is plus or minus square root of 1/2.
Mm-hmm.
And then added 3 to both sides.
Awesome. So there's one thing. Can we keep a square root in the denominator?
No.
Right. So what do we have
You'd
to
have to multiply by the denominator.
Yeah. So when we separate that square root to root 1 over root 2, we know root 1 is just 1. So we're going to multiply the top and bottom by root 2. And what do we end up getting, Jordan?
Would it be root 2 over 2?
Exactly. Awesome. So when you plug those into your calculator, one being addition, then the other one subtraction, you will get 3.7 as one of them, and then 2.3. All right, and then we will go and plot all of our information. And so obviously we don't have that 0, negative 17 on here, but we know it's going to be way below. So we know this is going to go down fast. Questions on this one? So those two are both vertex form. So now we're going to look at intercept form. So that form is y equals a times x minus p and x minus q. So our x-intercepts of this form are that p and q. And notice here that negative is a part of the formula. So just like that h in our vertex form, we have to remember that negatives are part of the formula here. They're part of the form. So our axis of symmetry is halfway between these x-intercepts. So if it's halfway, then we're going to add them together and then divide by 2. So our axis of symmetry equation is p plus q divided by 2. And of course, if the graph opens up, a is greater than 0, and down if a is less than 0. So now we're going to graph quadratic functions that are in this form. And we're still finding all the same characteristics: axis of symmetry, vertex, and intercepts. So here, I'm going to start with our x-intercepts since we can see what they are right off the bat. Right from that form, I know my first intercept is 1, 0. Because remember, it's just that number following that negative sign. That negative, that subtraction is in the form. So then, Alyssa, what's our second x-intercept here?
5, 0.
Good. So now we have the x-intercepts. Now I'm going to move to our axis of symmetry because I'm going to use those x-intercepts to find that. And we need that x coordinate for the vertex. So using that x equals p plus q over 2, we're just adding those intercepts. We would have 1 plus 5 divided by 2, which is then 3. So our axis of symmetry is x equals 3. Okay. So now you can go on to get your y-intercept or your vertex. I'm going to do our vertex since we just got that x coordinate. Ava M, how do you think we're going to find our vertex? What should we do? We have this axis of symmetry at x equals 3.
You plug x in to find y.
Yeah. So we're just going to plug that x in. This gives us -2 times 2 times -2. This gives us 8. So then our vertex is our x from our axis of symmetry and that y we just found. So it's 3, 8. And lastly, our y-intercept. And we're just setting x equal to 0. So I'm just going to go ahead and plug 0 in for those x's. We get -2 times -1 times -5. And that gives us -10. So our x-intercept is 0, -10. So these are nice. Different forms make certain calculations easier. Before in the other forms, like standard form, that x-intercept was always the annoying one to find because we'd have that big formula. Here, we just get them right off the bat. All right, so now let's plot our information. And of course, we don't have that 0, -10 on this graph. It's okay, but we know it's going to go down. And now we just graphed that function there. Questions? All right, go ahead and try part B. I'll give you a minute or two to do that. Ella, what did you say your x-intercepts are here?
My x-intercepts were -2, 0, and 1, 0.
Awesome. Gabby Soul, what is our axis of symmetry?
I got -1/2.
Yeah. We're gonna add them up, and we get -1/2. Good. Our y-intercept, we're plugging in 0 for x. Brooke, what did you end up getting as your y-intercept? What about Alyssa?
Oh, I'm sorry. I was still muted.
It's okay. Go ahead, Brooke.
-6, and then the intercept would be 0, -6.
Good job. And then lastly, we have our vertex. And so I did this after the axis of symmetry last time. We know we are plugging in that -1/2. And you end up getting -27/4. That's the fraction form. So then our vertex is -1/2, -27/4. And that'd be beneficial for you to get a decimal so that you can see where to plot it. So that's going to be a little bit over 6. So our axis of symmetry is at -1/2. And that point is going to be somewhere down there. Our y-intercept is at 0, -6. And our x-intercepts are at -2 and 1. So using the axis of symmetry, Helene, what other point can we plot? So we know
would
it.
it be
Go ahead.
like -1?
-1, and then what's the y coordinate?
6.
Yeah, right there. Because we know every point is reflected over that axis of symmetry. And there's our graph. Questions on this one? So just different forms, some forms make it easier to find other characteristics. Cool. Okay. So now, what if they asked us to change this function from intercept form to standard form? So this is an intercept form. We can read our intercepts right off of that. It'd be -2 and 5. And we want to get this to standard form. Standard form is just that y equals ax squared plus bx plus c. So we could just do that by foiling. We could FOIL those binomials and then multiply in that 3. So when we FOIL that binomial, we'd get x squared minus 5x plus 2x minus 10. Combining that -5x and 2x would give us -3x. And then we'd have to distribute that 3. And we have it in that form. So standard form is just everything multiplied out in that ax squared plus bx plus c form. So we just changed that equation from intercept form to standard form. Here, in the next example, they're asking us to change this function from vertex form to standard form. So standard form is still that everything's multiplied out, simplified, like terms combined. It's in vertex form. Jaden, how do you think we should go about getting this from vertex form to standard form?
Would you take the x plus 2 and square it?
Yeah, so
Yeah.
that x plus 2 squared really means we just have 2 of them, right?
Yeah.
I'm just going to rewrite it. And this is very similar to intercept form above, how we have those 2 binomials being multiplied by one another. And Jaden, what do you think we should do next here? How could we simplify?
Would you FOIL the x plus 2 into each other?
Yep. Let's FOIL that binomial, or the 2 binomials. Then we're just going to continue to simplify and combine like terms. I'm going to combine those 2 x's in the middle. Multiply in that -5. Distribute that through. And then what else could we do? What's the last step here? Grace, what's our last step here?
Take -20 plus 8, which is -12.
Awesome. And we just changed it from vertex form to standard form. Okay. Okay. So that is all the notes I'm going to do with you today. Your homework for tonight. Oh, it's not on here. If you head over to Google Classroom, it looks like it just posted. It's another outline of a practice worksheet. So this is going to have you graph in vertex and intercept form, how we did in class. The first 3 problems have you just match the graph to the function. So looking at what you're given, try and determine what function it is, and then you have graphing problems. And they all give you space and have the graph on there. So that is all I have for you today. If you have questions on the homework from last night, stick around, I can answer them for you. But put your questions in the Google form and have a great weekend. I will see you on Monday.
Have a good weekend.
Thanks, you too.